Hello everyone. Our next chapter is limits and continuity. This chapter comes for 2 and 4 marks. In order to solve the questions, we have to remember some formulas. So the first formula is if limit x extends to a and x power n minus a power n by x minus a is equals to n into a power n minus 1, and limit x tends to 0, tan x by x is equals to 1. Limit x tends to infinity into 1 plus 1 by x whole power x is equals to e. Limit x extends to 0, a power n minus a power m n by x power m minus a power m is equals to n by m into a power n minus m. And if limit x extends to 0, tan ax by x is equals to a, and limit x extends to 0, sin x by x is equals to 1. Limit x extends to 0, 1 plus x whole power 1 by x is equals to e, and limit x extends to 0, a power x minus 1 by x is equals to log a to the base e. Limit x extends to 0, sin ax by x is equals to a. Limit x tends to 0, e power x minus 1 by x is equals to 1. And the thing is, we have to find whether the function is continuous or not. In order to find its continuity, we have to know one rule, that is, if the function f of x extends to a is equal to f of a, then only the function will be continuous. In this case, it will be continuous. And the another case of continuity is if the right hand limit plus is the right hand limit of the function positive will be equal to the left hand limit of the function negative of a x extends to a. Okay, then the function will be continuous. When we solve the problems, you will know how this has been applied. So our first question is, if f defined by the function f of x is equals to sine 2x by x if x is not equals to 0, and 1 if x is equals to 0, continuous at x equal to 0. So we have to find that this function is continuous at x equal to 0 or not. Okay, so we have to write limit x extends to 0 of the function f of x. So it is limit x extends to 0. Our function is this. So it is sine 2x by x. Now we have already studied the formula. It is in the form this. Limit x extends to 0, sine ax by x is equals to a. So here the value of a is 2. So this function is equals to 2. Right? When we solve this function, when x is extends to 0, the function value is 2. Here it is said that when this function is solved, when x is equals to 0, it is 1. So the given f of 0 is equals to 1. Both the conditions are not satisfied. So we can say that limit x extends to 0, f of x is not equals to f of a, which is nothing but f of 0. Okay, therefore f is not continuous at x equals to 0. Next question is, check the continuity of f given by the function f of x is equals to x square minus 9 by x square minus 2x minus 3 if x is greater than 0 and less than 5 and x is not equals to 3, and it is equal to 1.5 when x is equals to 3. So we have to find this, the value of this function when x is equal to 3, because it is given at a point x equal to 3. So solution, limit x extends to 3 of the function f of x. So this can be written as, this is our complete function. So it is limit x extends to 3, function is x square minus 9 by x square minus 2x minus 3. Okay, this 9 can be written as 3 square, right? Limit x tends to 3, x square minus 3 square by x square minus 2x minus 3. Now we will find. Now we have to take the factors of this denominator. So our equation is x square minus 2x minus 3. So factors will be 3 ones are 3 and 3 minus 1 is 2. So we can write it as x square minus 3x plus x minus 3. Taking x common, so it will be x minus 3. Writing the same factor here, so we'll be left with plus 1. So factors are x minus 3 and x plus 1. I'll write here, so it will be limit x tends to 3. Here we can apply the formula a square minus b square. So it is a plus b into a minus b. So x plus 3 into x minus 3 by the two factors x minus 3 into x plus 1. Now the same factors get cancelled out. So we'll be remaining with limit x tends to 3, x plus 3 by x plus 1. Now we have to substitute the value of x in this equation as 3. So it will be 3 plus 3 by 3 plus 1. So it will be 6 by 4. So it is 3 twos, 3 2 twos. So it is 3 by 2. When we divide it, we'll get 1.5, which has been already said in the question that if this function in which x is equals to 3, the value should be equal to 1.5. We have got the same answer. So we can say that limit x tends to 3, f of x is equals to f of 3. Okay, so therefore f of x is continuous at x equals to 3. Our next question is, show that f of x is equals to cos ax minus cos bx by x square if x is not equals to 0, and when x is equals to 0 the function is 1 by 2 into b square minus a square. Both a b are the real constants and is continuous at x equals to 0. So this function, we have to solve this function, it will be continuous. So when we solve this, we'll get the value of this when x is equals to 0. So it is limit x tends to 0 f of x. So our function is limit x tends to 0 f of x, this all the function cos ax minus cos bx by x square. So now we have to apply the formula of cos c minus cos d. Cos c minus cos d is equal to minus 2 sine c plus d by 2 into sine c minus d by 2. This formula we need to apply. So it will become limit x tends to 0 minus 2 sine ax plus bx by 2 into sine ax minus bx by 2 whole by x square. Now taking x common in numerators in both the sine function, so it will be limit x tends to 0 minus 2 sine a plus b into x by 2 into sine a minus b into x by 2. Okay, I can write here, they are two x, right? One with this sign and another with this sign I will write. Okay, so this becomes the formula is sine ax by x will be equal to a. What is the formula? Limit x tends to 0 sine ax by x is equals to a. So here the a is this factor and here minus 2 is left, so we'll get minus 2 into, this is our a, so a plus b by 2 into the same here also, this is also our a, so it is a minus b by 2. Here 2 and 2 gets cancelled, so we'll be remaining with a plus b into a minus b will be a square minus b square, and we'll have this 2, so it is 1 by 2 negative of a square minus b square. Multiplying this negative inside, so we'll get the positive becomes negative and the negative becomes positive. So it will be 1 by 2 into b square minus a square. So we have got the same value because it is continuous. So we can say the given function f of x is continuous at x equal to 0, and it also satisfy the condition. I'll write here, limit x extends to 0, f of x is equals to f of 0. This condition is satisfied, therefore it is continuous at x equal to 0.